Starting off tonight with Night Owl Le Chop Stout from La Chop Brasserie. Not much in the way of tasting notes on the can, just calls it a strong beer, 26 IBU. But I have had this one before, and if I remember, it's a pretty nice beer. So tonight I'm looking at this interesting little trapezoidal black box. This is one half of a cell booster system. The branding on it is Cell-Fi. You can see it there. Other than that, it's pretty nondescript. Now, I guess I probably should explain a little bit. So there's a couple of different kinds of cell boosters. The more common kind of cell booster is set up kind of like this. You've got the device itself, you've got an indoor antenna, and you've got a long chunk of cable going to an outdoor antenna. And that outdoor antenna will be pointing at the closest cell tower to your house. That's how they're supposed to be used. At work, I end up getting annoyed by these things quite often because people haven't installed them correctly and have put the two antennas either too close together pointing at each other, and it causes a literal feedback loop in there. So you know the screaming, squealing of feedback when somebody points a microphone at the speaker? It's exactly the same thing, only at RF levels, and the result is it deafens the receivers at the tower, so nobody around can use their phones at all. Okay, I'm going to try and minimize my ranting. Anyways, this is the standard one. It's just basically two amplifiers, one facing each direction, frequency selective filtering, so that the uplink frequency gets filtered one way and the downlink frequency gets filtered the other way and only passed in one direction, so that it doesn't create a feedback loop inside itself. This Cell-Fi unit, though, this is different. This unit needs two different modules. This is one of them. The other one I wasn't able to get my hands on. This was a dumpster dive sort of pick at work. I don't know why it was going in the garbage, and I don't know where the other half of it is, but it's two units basically. This one is what they call the network unit. This is the one that communicates with the cell tower. You're supposed to place this thing near a window, up on the second floor, somewhere that you can actually pick up signal. And if you don't have any place like that, then you connect a cable and an outdoor antenna, just like that other system, only you run it up to wherever you can get a signal from. Other than that, the only other interface on it is a power plug down here, a single button on the top, and a little LCD. I'm getting a little bit chaotic here. Going back to how this thing works. So this one creates an RF path back to the tower, to the cell tower, and then it translates that set of frequencies into 5 gigahertz, which is one of the license-free frequencies that your Wi-Fi uses. So that 5 gigahertz signal communicates from this to the other box, which turns it back into cellular signals inside your house. So then the link between this and the other box, which you've put somewhere deeper inside your house, in your basement or whatever, these two only need to communicate with each other, and then the one inside the indoor unit, the coverage unit I think they call it, actually communicates with your phones. But anyway, I'm not here to do a sales pitch for these guys. Like I said, this was a trash pick, so I'm not even sure if it works. But I'm going to start pulling screws out and see what's inside it, because that is the real reason that I got it. First off, there's this little door on the back that looks like it's something obvious to take off. Oh, hey, there's a USB connection on the back of there. I'm assuming that's for programming it. So this unit, this system, another thing that helps keep it from interfering is when you initially set it up, or when it's set up by whoever sold it to you, you set it up for the specific network that your phone uses, and it recognizes just that network, so it doesn't even talk to any channels that aren't using that network. So that further helps it reduce interference with the world. Now, again, I'm not going to plug into that because I don't have any software for it. I'm assuming it's proprietary. There is apparently an app for this thing for your phone or whatever, to Bluetooth to it to initially set it up. I'm not going to do that either because I don't have the other one, so I don't really feel the need to. But according to the documentation that I found, that software lets you basically tell this thing what network it needs to talk to, and then it will just stay with that one and not cause problems. Apparently, there are some things that you have to do if you're moving to a different location than where it was initially set up. I think you have to go into the app again, but again, I'm not too concerned about that and all the software. So there's all those screws out of the bottom there. So will that start coming apart? Nope. Come on! Ah, there. Okay, looks like I had to... Man, did they actually glue that? What the hell? Yeah, so it was held by clips all the way around, screws on the bottom, pins up at the top there, which apparently I had to break. Okay. Structural Kapton holding... Is that an antenna? I think that's an antenna. No, that's a shielded ribbon cable going up to the display board up at the top. There's one antenna up the side there. Another one up that side. And they look like the traces are slightly different size from one side to the other. This one looks like it's got a little bit bigger loops on it than this one does over here. So different frequencies. And what are we seeing up in the front there? I'm guessing that those two are also more PCB antennas. So this thing claims to be able to talk to 4 channels at once. So that would make sense. If it can maintain 4 different RF pads back to the cell tower at once, that would kind of make sense. And I'm seeing more different kind of antennas in there too. Okay, I'm going to see if I can figure out how to get this thing further apart. I'm seeing some more little pin things like that up front there, and more along the side here. Kind of like to figure out how to get those apart without destroying them. Not that I'm intending to, use this thing or put it back together or anything, but this is going to be a one-way teardown. Okay. Oh, maybe not. Maybe not. Maybe I can do this slightly less destructively. Okay, bezel is off, revealing a bunch of little screws around here. Okay. And there the screen comes off. Right. Is that plugged in? Wow, there's a lot of Kapton on there. So there's the back of the screen. Let's see if we can lift some of this Kapton out of the way and unplug that little flex cable. Wow. That is, it's a heavy RF environment, so obviously it's going to be well shielded. But wow. This piece of copper tape holding that down. I'm pretty sure that's a standard flat flex cable. A connector. So there it is. One tiny little tact switch and this screen on its own flat flex. Not sure if I'm going to be able to find a driver for that, but oh boy, would that be a handy thing to keep in stock just in case I can. Okay, there's no real display drivery stuff under there, just some passives. So it's either on board the display or at the other end of this cable down inside the machine somewhere. Right. Save that display for later. Could come in handy for something. And continue to delve deeper into the belly of the beast. Now then, I think, does this just pull off there with those screws? Yeah, there we go. Antennas all around. Wow. So here is those 2 PCB antennas that we saw initially. And their coax cables going down into the bottom. Underneath even more Kapton tape. And disappearing down into the bottom. So there's those 2 back there. There's this little patch antenna here. And another one there. Which are the same part number on the board, so they're going to be the same. That was 109-001, that's 109-002. Yeah, so those 2 are different. -003-004. So those 4 PCB antennas are for the 4 different channels that this thing can talk to, the 4 different RF frequencies. This is another different one. So 4 cellular, 2 probably for Wi-Fi, 1 probably for Bluetooth. That's my guess, unless something changes my mind later. So how do we get the next layer down? Oh, there's one on the front and one on the side. Ah, little fan. This thing just keeps showing its mysteries. Okay. So there's that cosmetic base out of the way. Now what do we have? So there's some fairly significant heat sinking going on down in there. And we got a board up there with a couple of different RF cans on it. And then a board down here with 1, 2, 3, 4, 5 RF cans on it. Oh, actually those heat sinks are on top of RF cans. So there's 2 more there. Wow. This being very much an RF product, there's going to be a lot of black magic in here, which even though I've dealt with RF for decades, I am not a designer and I am not going to try and explain at the deepest levels because it's just black fucking magic. Okay, here's the easiest one. The fan plugs in over here. Cool. That we understand. Continuing with the things that we can probably understand. Power comes in there, goes through a diode, some capacitors, some inductors, a little chip of some sort there, another capacitor, some 0 ohm resistors, LP29, probably. LP2951, that makes more sense. Here it is here. It is an adjustable micro power voltage regulator with shutdown. Of course it is. Why wouldn't it be? So I'm pretty sure the next step is to yoink this board off and see if there's anything that's not hidden in an RF can on the other side. I am not holding my breath, but you never know. Why won't that come off? Oh, that's got that in the way. Okay. There we go. 2 more boards. All right. This one has all the RF connectors coming down from the antennas and then some that are crossing over onto there. Actually, no, that's not true either. Some of the antennas go to this one, some go to that one. I'm going to see if I can pull those antennas off without completely destroying them. I assume they're just glued in there because why wouldn't they be? Yep. Okay, that's not too ugly. And then the cables are all clipped under those things. Okay, I'm going to do that kind of action just so I can get everything away from this casework so we can see it all in one. There. And get rid of that plastic. Remind me to salvage that fan later. So it looks like this one over here, this board over here does all the cellular stuff. There's the outdoor antenna. It's actually plugged in. Okay. Ooh, tiny little connector. And this one has these 4 antennas, which I assume are other cell antennas. Are those plugs? Oh, those are on. They're all on these little plugs here. They're just glued in place. Okay, so I can force them and pop that glue off. And then that board is connected RF-wise by plugs over to this one. Unplug those. And then there is this little flat flex here. Which, how do you pop open? It's that style. Okay. There, got the boards separated so we can look at them individually. So this one that had all the cell antennas connected to it, it's got a big ground plane on the back of it. And then it's got this daughter board on it. Huh. And then these 4 antenna lines, 1, 2, 3, 4, seem to have little amplifier chips associated with them. I don't think I'm going to go and look all these guys up, but there's what it is. And I can't imagine that that is anything other than a preamp for those antenna lines. Okay, so this looks like filtering going on here. And just judging by the shape of those blocks and some inductors in there and stuff like that, I'm going to guess that these 3 make up an RF filter network. And I'm guessing that is just power and control for these guys. Which leaves this board, which was the first one on the bottom there that we looked at. Let me just, wow. They used a lot of adhesives on this thing. This copper shielding tape, or in this case, looks like they're actually using it to bond that shield to the shield on the wire here. That little flat flex pops out, okay. And yeah, all these RF cans are soldered down. And then these three antennas here. I'm going to guess that those are probably, what did I say before? Actually, two of them are one type and one is the other type. So the two of them are probably the RF connection at 5 gigahertz to the other unit that I don't have. And that one, maybe it's Bluetooth, I don't know. But again, they're on these little funky little connectors here. Teeny tiny little connectors. Let's see now. Those will be digital signal processing happening underneath there. Maybe I should rip one of those off. I'm not going to bother heating it. I'm just going to get all medieval, I think, and pull it off the ugly way. I don't know that I'm going to be able to heat it to remove it. I use my damaged old cutters that I don't use for anything nice anymore. I'm just going to chop that off there. Avert your eyes if you're squeamish with gore. Okay, so first of all, this is kind of cool. It's got these ribs that go down to the board, and they were soldered down too to transfer heat up to that heat sink. Those were soldered down to there and there and there. Actually, are those heat ribs or are those shielding different parts of the circuit from each other? Huh. Anyway, there's 4 big chips in here and a bunch of little tiny guys all doing interesting things, I'm sure. Let me just take a look and see if I can figure out what one or more of those chips is. I guess this shouldn't be any surprise. Small cell power amplifier module, 1.93 gig to 1.995 gig. And the other one is the same thing, only between 860 and 894 megahertz. And that makes sense because this is this particular model of repeater that we've got here. And here are the 4 sets of frequencies that it works at. So there is these frequencies and there is these frequencies. So without invoking any more of the old ultraviolence, I'm going to guess that this particular one has 2 more of those same chip, only tuned for different frequencies again. How much further do I want to go into here? I think I'm going to look at this one because that's the one that's on the back side of the power supply. So it might have some less RF stuff in it, but still things that are interesting to look at. As you notice, I'm becoming more and more gentle with, more and more abusive with this thing. So that's definitely power supply. Look at all those little inductors. After much Googling, those come up absolutely blank. No idea. But I'm going to stick with my initial gut reaction and say that they are probably power supply switching type regulators, controller with working with these capacitors and these inductors to create power supply stuff, especially since they're directly above the main power input and the input smoothing capacitors and stuff. So I'm gonna go with that. Shall we rip into one more of these little shielding cans? That back-to-back pair or this back-to-back pair? Let's get the smaller ones here. And again, I apologize to anybody who has a sensitive stomach for the gore that I am inflicting upon this thing. Oh, there's some brain power in there. What is that? Maxim Max 2850. That shouldn't be that hard to find. Aha! There is the 5 gigahertz 4-channel MIMO. So that will be the transmitter that is communicating with the companion unit for this one. It's designed for wireless HDMI. That's kind of cool. 20 or 40 megahertz of RF bandwidth, but that isn't the data bandwidth. There we go. 4 times 54 megabits per second, 1 per channel, using orthogonal frequency division multiplexing. Okay, so that's essentially 200 megabits per second plus overhead. So that's reasonable enough, I guess. So if that one is the 5 gigahertz transmitter, then I'm going to assume that back behind it here is the 5 gigahertz receiver. Which just makes sense, doesn't it? Why wouldn't it be? Max 2851. Yep, of course it is. That makes perfect sense. So specs are all going to be the same, just this one is the receiver, which works alongside of the transmitter on the other side of the board. So I know I said I wasn't going to take all of these cans off, but each one's got different stuff under it, so now I'm going to. Ooh, Custom Silicon. Nextivity is the maker of this Cell-Fi. So I'm going to guess, since that's Custom Silicon, that I'm not going to be able to figure out what their processor is. Which kind of sucks, because that's obviously what that guy is doing. Yeah, I didn't think I would be able to find it. It is a Nextivity purpose-built high-performance 6-core ASIC. Maybe I'll have better luck with some of its support chips. I don't know. Yeah, no real surprise. That processor type chip has 128 meg of DDR and 128 megabits of serial flash memory, both associated with it. Of course it would. That's what self-respecting processor wouldn't have a bunch of memory scattered around it. I guess we can check what's on the back side of that main processor section. I don't know whether it'll be anything interesting. More processor, more RF. What do you think? This seems to be the most reasonable way to get these things off in a hurry, assuming you don't want to put them back on again. There's nothing back there. That's just support stuff. That's just support components. Okay, there's one little chip there, but I'm not going to bother. Nah, I'm not going to bother with that. It's going to be the same as this RF section over here. Well, there was a lot going on inside that. Some really powerful little chips, some kind of interesting layout, a lot of custom stuff. That's pretty cool. And I guess that makes sense. In order to do all the encoding and decoding and everything else that they're doing, they would need a lot of that high-powered silicon. That's pretty cool. Oh, I hope somebody found that interesting. I certainly did. I've always kind of wondered what's inside this kind of thing. The older style, the ones that I don't like, they are just going to be amplifiers. But this thing is actually doing signal processing. It's recognizing that it is talking to a tower belonging to the carrier that you're set up for, and only processing that carrier signal. So there's a lot neat going on in here. Not really hackable. It is all single purpose stuff, but cool nonetheless. Anyways, questions and comments down below as usual. Thanks for coming along for the ride on this one. Talk to you later.